Okay. So let us, so this graph is plotted for this particular processes P1, P2, P3 and P4, and this considering that P1 needs 6 milliseconds of CPU burst, and P2 needs 3 milliseconds of CPU burst time, and P3 needs 1 millisecond, and P4 needs 7 milliseconds of CPU burst time. Okay. So this graph basically it calculates the average turnaround time. This graph is plotted for the average turnaround time considering different values for the time quantum q. Considering different values for the time quantum q. So if q is 1, then what will be the average turnaround time? So that is what this 11 is. Okay. If q is 2, then what will be the uh, average turnaround time? That will be 11.5. If q is 3, what will be the average turnaround time? That will be somewhere around 10.8. If q is 4, what will be the average turnaround time? Again 11.5. Okay, like this it was plotted. So for different values of q for this particular process with this particular time slice of CPU, this graph was plotted. Okay, let us assume for one case, let us discuss. Let us assume q is 1. Let us assume the value of q is 1. Okay, that is the CPU is going to context switch after every 1 millisecond. After every 1 millisecond, the CPU is going to context switch. So if you draw a Gantt chart for this, really it is going to be little big. Okay, but let us try to draw that. So this is the order of the process. First there is P1, then P2, then P3, then P4, and each will get only 1 millisecond. So in the first round at 0th millisecond, P1 will get 1 millisecond. Okay. Then P2 will get 1 millisecond. Then P3 will get 1 millisecond. Then P4 will get 1 millisecond. Okay. So after one round, what happens? So this is one round. One round is completed. Let me mark this. So this is one round. One round has completed. So the first round has completed at 4th millisecond. So now the remaining time for each of the processes, for process 6 it will be 5, for this it will be 2, process 3 has finished. Process 3 needs only 1 millisecond, so it already completed. Process 4 has 6 milliseconds. So in the second round we have only 3 processes, P1, P2 and P4. So in the second round, first there will be P1, and then there will be P2, and then there will be P4. So this is round 2. This is round 2. Okay. So in the round 2 we have only 3 processes, P1, P2 and P4, because P3 has already finished. So round 2 completed at what time? 5, 6, at 7th millisecond, round 2 has completed. So after round 2, if you see what will be the values of all these things, it will be after round 2, P1 will have 4 milliseconds left over, P2 will have only 1 millisecond, P3 has already completed, and P4 will have 5 millisecond. Okay, P1 4, P2 1, P3 finished, and P4 5. Okay, so this is the remaining time quantum required. So in the third round also, all these 3 processes will continue. That is P1, P2 and P4. P1 will first execute, then P2 will execute. Okay, then P4 will execute, right? So P1, that is 8, 9 and 10. So the third round will complete at 10th millisecond. This is round 3. This is round 3. So round 3 goes up to 10th millisecond. After round 3, what happens? The remaining time will be for process 1, 3 millisecond. Process 2 has already finished. Process 3 has already finished. and process 5, the remaining time will be 4 milliseconds. Okay, so now in the fourth round there will be only two processes. What are they? P1 and P4. P1 and P4, only these two processes will be there. So P1 uh, will execute for 1 millisecond, and then P2 will execute for 1 millisecond. So that is the fourth round will complete at 12th millisecond. Okay, so this is the next round, which is fourth round, which completes at 12th millisecond. So after this, what happens? P1 is 2 and P4 is 3. P1 is 2 and P4 is 3. Okay, so after 4th millisecond, P1 needs 2 more cycles and P4 needs 3 more cycles. Okay, so again now P1 will execute for 1 millisecond, and P2 will execute for 1 more millisecond. Okay, that is P1 will complete at 13th millisecond, and P4 will release the processor at 14th millisecond. So this is at fifth round. This is at fifth round. So after fifth round, P1 need, after 5 rounds, P1 need 1 more millisecond to complete, and P2 needs 2 more milliseconds to complete. Okay. So during the next round, what happens then? Again, P1 will execute first. Okay, and then P2 will execute. So what happens? P1 will release the CPU at 15th millisecond, and P2 will release the CPU at 16th millisecond. Okay, so after this particular round, P1, so this is sixth round. This is sixth round. After sixth round, P1 completes. P1 becomes 0. P1 needs no more time. P4 needs 1 more millisecond. P4 needs 1 more millisecond. So now there is only one process left over, that is P4. That is P4. So P4 needs 1 more millisecond. So it will execute for one more. Sorry, here it is P4. It should be P4. I'm mentioning as P2. This is P1. So after third round, P2 complete. So it is P1 and P4. Everything is P1 and P4. This is also P1 and P4. Okay. So the last round, P4 executes for 1 more millisecond. Okay. So P4 now completes at 17th millisecond. Now this also has become 0. So now it is completed after 6th round, after 7 rounds totally. Okay, after 7th round. Okay, so now you can calculate what is the turnaround time. So what is the turnaround time for P1? What is the turnaround time for P1? So if you see, P1 completes at 15th millisecond. So here the arrival time for all jobs is 0 millisecond. So it is completion time minus arrival time. So 15 minus 0 is 15. So the turnaround time for P1 is 15. And what is the turnaround time for P2? P2 completes in the third cycle somewhere here. So its completion time is 9. So 9 minus 0 is 9. Okay, and P3, what's the turnaround time for P3? P3 has finished in the first round itself. That is at third millisecond it finished. So its turnaround time is 3 minus 0, 3. And P4 is the one which finished at last. Okay, so P4 completes at 17th millisecond. So its turnaround time is 17 minus 0, that is 17. Okay, now add all these things and divide it by 3. So when you do that, what you get is, if you add all these values, that is 15 plus 9 plus 3 plus 17, which is 44. Okay, so 44 divided by number of process. So number of process is 4. So 45 by 4 is the value. What you get is 11. So that is how you got this particular value 11. So 11 will be the turnaround time if the value of q is 1. Like that, you should calculate what will be the turnaround time if q is 2, and what will be the turnaround time if q is 3, 4, 5, 6, and 7. Okay. So that I leave it as a homework which you try to do and revert back. Okay. So from this, what we can understand in the sense, here there are so many context switches. So the q value should not be too high and also it should not be too low. So generally it is suggested that the q value should be such a way that 80% of the CPU burst should be shorter than the q value. 80% of the CPU burst should be shorter than the q value. That is, if you have n number of jobs in the ready queue, out of that n, 80% of the jobs should have a shorter CPU burst time than the value of the queue. So that is what this particular thing suggests. Okay. So, so this is a homework which I want you to do. Calculate the turnaround time for the table of process in the previous slide, assuming time quantum as 1 millisecond, 2, 3, 4, 5, 6, and 7, and verify with the graph. Already 1 millisecond we have done. So you can do start with 2, 3, 4, 5, 6, and 7th millisecond. Okay. Yeah, so we'll stop here. So what we have discussed is round robin scheduling algorithm, which is a preemptive scheduling algorithm where every process will get an equal time quantum, and once the time quantum expires, the CPU will context switch to the next process. Here the queue is assumed to be a circular queue, and and it provides better uh, average turnaround time and average waiting time, but it will not provide an solution which is better than SJF, but compared to other algorithms, it performs quite well. And choosing the value of q is very crucial in this algorithm, where q represents the time quantum. Thank you.